Hello and welcome to another episode of Flutter Original. This episode is super special because we're talking about security. In fact, recently, well, if you watch this video later, you can find the video on my channel as well. I published a new video regarding security in Flutter and Dart applications, especially Flutter mobile applications. And we talked about the top 10 OWASP security risk for mobile applications. Today, I have two security experts, which they are going to talk about, well, security in mobile, as well as a very cool package, FreeRASP, which we will understand how it works and what it is. What is RASP? Jaroslav and Thomas are with me from Talsec. Welcome. Maybe you should introduce
Hello,
yours.
everyone.
Maybe you should introduce yourself, Thomas, first.
Okay, thank you, Majid. So I'm Thomas, and I'm security engineer from Talsec. Like I love hacking, and together with Jaroslav, we went today to prepare like a presentation of this new package for FreeRASP, which will show you a lot of ways how your application can be protected against threats. We are both like lovers of mobile security, and we can share a lot of really interesting insights into mobile security.
Nice. Thank you for being here, Yaroslav.
Hi, my name is Jaroslav, and I work as Flutter developer at Talsec. About 2 years ago, I just fell in love with Flutter, and since then, I've created FreeRASP, and I'm just really glad that I could be part of Flutter community since then.
Thank you very much. So let's start from a few questions before we jump into pair programming about FreeRASP package. I don't know who wants to answer. Feel free to just start one of you and then another one complete the, whatever you want to say. Just ask. I will ask just the question. First of all, when it comes to mobile security, can you, one of you, maybe explain what it means, what should be considered, and what are the common risks and issues that you see in mobile applications?
Okay, I'll take this question. So, mobile security is a really wide area with a lot of threats, and if I had to like guide someone to learn more about mobile security, I would point out to OWASP mass standard. Mobile security comes with a lot of areas which should be covered whenever you are developing application which has to meet the highest standards. And OWASP Mass gives you guidance in a majority of areas, starting from architecture, uh, cryptography, secure storage, UI, and other areas. But today, we are here to tell you more about reverse engineering and resiliency category, which has its own threats. And these are commonly threats to business owners and other people who need to have their application resilient against hackers. So, be it fintech, be it health sector, uh, the common threats in these areas are like routing, tampering, hooking, and you will see all these in the FreeRASP package later.
So interesting. So when we're talking about OWASP mass, as you said, so this is like a standard and it's been around for a while, and every while we get an update, and that's very nice to follow. And there are also like certain, let's say, tools and checklists and things that we can follow. However, so the package that you provided, FreeRASP, it comes with, well, of course, terminology here, RASP. I just wanted to ask a question here is like, what is this RASP and how can you see RASP part of these security issues and how it can help?
Like RASP, let's explain this weird acronym. It's Runtime Application Self Protection.
Mhm.
So this RASP technology is, let's say, a set of techniques which help your application, your client application, to self-protect any threats and combat any reverse engineers or hackers. And this technology is really new. Speaking of mobile application, has flourished about 6 years ago, but only now it's being widely accepted into wider public. And this covers a few areas from the mentioned OWASP standard, uh, especially uh, previously it was focused on routing, but nowadays it's moved to more to like overall protection of intellectual property of your assets because let's say you have some really expensive machine learning model which you want to protect against being stolen. So in that case, you have to put everything into your application to ensure that your IP won't be lost. So this is the motivation why people nowadays really insist on having RASP in their application.
Okay, interesting. So, for those who are not actually really into security, I would like to ask another question here. So, you're talking about runtime. Okay, that makes sense. That
Mhm.
means, well, we ship the application, something is happening later, which is out of our hand probably, and then that means runtime. But is there any other way that we can prevent like security issues or find them, fix them?
Yes, those are typically areas not covered directly by RASP, but we can talk about code obfuscation, code encryption. We can talk about various statistical analyzers, which will help you to ensure that there are no common issues in your code base because your code base can be statically analyzed and it's really recommended way to put some statistical code analyzer into your CI so your code is always uh, checked before it goes to
I
production.
see. So can we then say we have maybe two types of security analysis? One is kind of static, like in compile time, maybe while developing and stuff like that, and another one is kind of um, or dynamic, what we call it. So which we have it on runtime, and that is the area that usually RASP is going to help, right?
Exactly.
Okay, sounds
Mhm.
interesting. So let's talk about the free RASP package then. So now we understood that there are some runtime issues that may happen and we can detect. And then, well, there are also some mechanism that probably we can take into account and like protect our application. So you want to explain a little bit more about those mechanism and how FreeRASP package in this case can help.
So the question is what mechanism are in FreeRASP which provide you the much needed protection, right?
Yep.
So there is actually some part I would like to say openly, and that is that the FreeRASP itself in its core is not open sourced. And that is because while these methods for detection of various things are publicly known, we won't disclose how exactly will they defend your application from within and how they are put and organized internally because that would be early guidance for a penetration tester hacker, so we can't technically disclose how we protect you, but majority of these detections are like publicly known and available on the OWASP mass, or we also learn a lot from other mobile security
Mhm.
forums. So Let's speak about temper detection. So in that case, we control the checksum of application, we control the signature of application, and other common uh, common signs of application, which um, are like signs that application is healthy or not.
S-
So that's it.
Interesting. So I'll get back to you, Yaroslav, for how you implemented that. But I have another question. So some people also ask me about this. So if you're saying RASP is like uh, some mechanism to prevent like attacking a mobile application on runtime, so does it mean that anyone else apart from you like can go and like create another package and just follow the guidelines of RASP and then just have maybe an open source package? I mean, is that the case, or is it like, as you said, it's not an open source as its core? So does it mean like only one company, only one organization can just do these prevention?
No, there are other companies which also do these protections, or especially are specialized in RASP. What makes us different from these other companies is that we try to provide this solution for other frameworks, because RASP itself is not open source.
Mm-hmm.
The wrapper or plugin for Flutter is open source. You can open it on GitHub. You can open issue. You can do pull requests just like any other package.
Okay, sounds good. Maybe we should, but again, you're providing that for free. At least there's a tier of free, usage. Because that's the name of also the package, right? Free-RASP, I assume. So maybe we should get into the package and start implementing, and then um, I'm pretty sure more question will come up. Let's start pair programming at this point, if you agree.
Yeah, sure. Let's go.
So first question, Yaroslav. So I think the
Yeah.
first thing we should do is just add FreeRASP to our PubSpec YAML file as dependencies. I think that's the only thing we want to do. And this package, this plugin, let's say, it's supporting only Android and iOS, as far as I understood.
Yes. What we do basically that we just build special flavor of our native Android and iOS package, and
Mm.
then we just put it into Flutter plugin. So that's why we only support Android and iOS.
Okay. And I mean, generally, is FreeRASP only about, or not FreeRASP, like RASP generally? Is it just about mobile, or can it also cover web at some point?
RASP is more concept. It is not tied to some concrete technology or platform. So RASP can be at some point implemented on web as well.
I see. Okay, sounds good. Do you have any plan, like maybe add web at some point to FreeRASP?
We actually had issue for that, and there's discussion in our team about that, but not in foreseeable future
I see.
or in near future, at least.
Because one of the things is that like Flutter is cross-platform, right? So we simply support 6 platforms in Flutter. So I'm just wondering, like, do you have plan to extend the support of platforms to other platforms at some point, or you just want to keep it for now Android and iOS?
Yeah, we have discussion about that, and we we actually are doing some internal discussions if that's what we want or in what timeline if we want to. So
Nice. Good. So, well, I encourage everyone to just check out the GitHub repo and maybe open an issue and just press the thumbs so they support more platforms. Yaroslav, then let's move on. So you added already to PubSpec YAML file. Maybe you want to show us quickly and then we jump into the code.
yeah, sure. So actually, I have already edited it. So the newest version is 4.0. So there you have it, FreeRASP. let's run pub-get just to make sure that everything is all right. Yep, seems all right. And also there is one constraint which you can read on the README on integration guide. We also have to check minimal SDK level for Android, which is 21. Yes, that is correct. So now we have all the hassle after us, so we can do an actual implementation in Dart.
Nice. Is there any restriction for iOS though?
Yes, there is minimal iOS level of iOS 11. Yeah, that's the
11.
lowest supported.
So as soon as we have 11 and in Android SDK 21, then we're good to go after installing dependencies.
Yep.
Sounds awesome. Let's just see how we can implement then.
So let's add import here. So that, whoops, FreeRASP Talsec boom. This import actually imports everything, but you can also import by parts. So that's why I'm using this one big umbrella import. So first, let's do little walk around code because there is already some prepared code. What we have here in root is stateful widget, which is then in runup. We also override the init state of this stateful widget. The only thing it calls is init Talsec, and what init Talsec does is what will we be doing. We will integrate it, and also we have add check, which is some, let's call it pseudo state management. What it does, it adds a string to our list, which will hold how many checks or how many threads were detected. And these checks are then viewed in our list view. So when a thread is detected, it will be added to the list, and the list view will rebuild, and we will see that this check did not pass.
Interesting. Okay. So if we want to summarize it then quickly, if I understood, if you go back up, then so we started from the root up application
Uh,
or
yes.
no? Yes. Okay. There you go. All right. So let's
So
see.
yeah, let's implement it. So let's implement our init Talsec function. So the first and most important thing we have to do is actually create Talsec app. So let's do that. Let's have final app equals Talsec app. Now, Talsec app requires two things, which is configuration and callback. So let's do just that. So Talsec config actually takes Talsec config object. So let's create that. And what Talsec config takes is WatcherMail and Android config or iOS config. WatcherMail is required, but you can also pass now if you don't wish to send any security reports, or then you can pass Android config and iOS config, both of respectively. So for example, if you don't use iOS, you don't have to pass iOS. Since we are implementing for Android, we are going to pass Android config. Now we will just leave it empty, and also watch your mail.
So then
So
watch email, as you said, it's for sending email, right?
yeah,
So does it mean like I need to have like what is it exactly? Like when do you send an email and what do you send? Where do you send?
yeah. Every time the thread is detected, it is now callbacks is fired. We will see that, but not only that, but this incident is also reported and is sent to backend. Backend then every week do a big audit, and you will get your pretty report to given watcher mail. In this report, you can see how many of each of these threads were detected, how many roots you were, how many incidents in general were detected. This can give you a good picture about how safely your users are behaving, basically. And also,
Interesting.
can you give you some hints about some trends? For example, when you see that routing is straight up, you can see that your Android users are preferring, for some reason, routing devices more and more.
Interesting. Okay, let's move on
So
then.
let's just fill here my mail. Talsec that up. And now let's resolve this yelling Android config. So what it actually requires is expected package name, then expected signing certificate hashes. So let's pass just that. So first we have expected package name. Expected package name is string, of course, and it basically tells us what kind of application ID do we expect when we release our application to Play Store, let's say. Uh, this is actually created when you create application. You have this window and you have their organization ID or something like that. But if you don't remember, which which is pretty common because nobody really often remembers, you can actually find it here in build.gradle under the Android file, and you can see here application ID. So basically, you take this and you put it there. What is useful about this is the fact that many times attackers try to repackage the thing and they try to upload it to the Play Store. Problem is that if they would try to upload it with the same expected package name, it just wouldn't go because Google expects every package name to be different. So that's one kind of check, let's say.
Interesting. Can I ask a question? So, can we get the package ID from like another plugin? There's a plugin named Package Info Plus, right? Which actually I'm one of the maintainer. I wonder, like, if we can use that instead of having this string here. So, if, for in case if we change the package ID, we don't
Mm,
need to change this here, so it's just automatically detected.
yeah, I know where we're heading. The answer is no,
Mhm.
because when attacker actually changes the package name of application, what would package plugin do? He would put it, but he would put it with the wrong package name, so it wouldn't work because what you do here, you want to hard code this. Problem with plugin package you mentioned is that he will put it dynamically, so he will put the most recent value he found, and what
Yeah,
he will found is the changed value by
I
the
see.
attacker.
Okay, good to know.
So let's format it so it's nicer. And the second thing we will fill here is expected signing certificate hashes. A terrible name. What it really means is that every application, when it's uploaded to Play Store, is signed by key. Actually, every run is signed by key. For example, you can actually see here that when you do release type, you are
Yeah,
signing your applications with debug key.
yeah,
We are going to use this right now, actually. So what we do need to fill here is hash of that signing key. We don't
yeah,
fill here directly signing key because then it would be easy stolen. But if you
yeah.
just paste hash here, it just, even though it would be stolen, it wouldn't do much damage anyway. So
Hmm.
what we can do to get signing hash, we can actually switch to Android. By the way, you can do that when you go, at least in Android Studio. You can actually go File, Open, and within the same project, you will just choose Android. So Android Studio will think that he is working
Yeah,
with Android project now. So let's go back here and right here, there's like a bunch of stuff. Maybe many people won't understand it because they are not native developer. That's fine. That's completely fine. We don't need to do changes here. What we will do is that we will run Gradle task, SSH signing report. This is just a small script which will tell us what are our signing keys. Now we are looking for debug key. So let me just variant release config debug. This should be it, if I'm not wrong.
Should we use SHA
SHA
256?
256. Yeah, I will. I will show you one useful trick actually, because there's this thing while signing hashes can basically tell any string. I can just put some trash here and it will take it. Actually, what you have to put here is signing hash in base64 format. When
Mm-hmm.
you see this, let's do some var here. So for example, hash, let's call it, boom, boom. This is not base64 format. This is just
Yeah,
plain X as we know it. So because many people were putting this hash here, this hex hash, we decided to provide useful utils to actually do conversions, so they can actually put the real value here. So
yeah.
let's do final base hash, let's call it, and it's hex. Actually, I don't remember. But that's what good about documentation, right? We can go to
Absolutely.
documentation. You see, even I as creator forgot what I created.
That happens a lot. So in this
Yeah.
show, yeah, it happens. So I had actually some authors that they forgot they implemented some method completely. So they re-implemented on the show. So that's fine.
Oh yeah, hash converter. Okay. So we create this util, which is hash converter. Yes, it should do import automatically. Yes. So we do from SHA to base64. You can do even other way around, but let's do
Yeah,
this. And let's put here hash. Boom. So this actually returns types string. It should be. Yep, type string. So that's what we'll put here. That's base hash.
nice.
The other, but that's clearly optional thing we can implement here is supported alternative stores. What this is trying to tell us is very oftentimes some developers want to upload their application to different stores. For example, Harmony OS from Huawei have different store, there is Samsung store, and so much and so on. We provided this field so you write here your supported stores where you want to place it. By the way, Google Play is supported out of the box, so you don't have to put
Google Play.
Play Store here. But what I will put here is ADB. What this
Mm-hmm.
means that it won't yell when we are running this on emulator, because emulator actually installs applications using ADB. But that's for now. When we remove it, it will be yelling that we are installing from untrusted source.
I see.
So that's about
But
Android.
I have a question here.
Yeah.
So emulators are also considered as not a secure environment.
Yep.
So how can we justify this? Like adding an ADB, but then we're also running that on an emulator.
Yeah, I need to correct myself. This tells us from where the application is installed.
I see.
On emulator tells us that the application itself is running on emulator. What this tells us is that okay, you can install it from using ADB, because
Okay,
maybe some
now
developers
makes sense.
don't mind like where did that get APK. If it's a valid one and it's not wrong or corrupted in some other way, I don't mind that you are using ADB.
Okay,
And
that makes sense.
so, yeah, that's about that. So we have Android config. Maybe just a little side note, when we would do iOS config, it's really the same. You just take different parameters. It takes upteam ID, which is pretty much same as expected package name, and bundle. App bundle ID is much same as expected package name. Upteam ID is very much same as signing hashes,
I see.
and this value can be found in Xcode.
Yep.
So let's go to callbacks, the second part. So callbacks actually takes object Talsec callback, which itself has two big groups, which is Android callback and iOS callback, and one common callback, which is on debugger detected.
Mhm.
So let's implement on debugger, which is basically function, or it takes function, because everything in Dart is object, so it takes void function. As you see, it's nullable, so if you don't wish to implement any callback, you don't have to. You
I
can
see.
implement only those you want to. So I'm gonna use arrow syntax here. So, and what we will do in our example, we will just add check and call it debugger. Let's format it so it looks nice. So
So
what
this callback, the debugger detected, is it happening only once?
mm, some checks are one time and some checks are periodic. For example, root detection are periodic because there are ways when you can do, it's called dynamic routing. So basically you are routing your phone on its runtime. On debugger, I'm actually quite not sure.
Yeah, okay.
I will have to confront the documentation. So uh, since we are implementing Android, we are going for Android callback, which is taking Android callback. And let's see what all of callbacks are here. Whoa, there are 1, 2, 3, 4, 5, 6 callbacks. So let's go through them all. Temper detected. Temper detected callback is fired when some issues with application signing integrity is found. That means, for example, when expected name wouldn't be the one we are expecting, for example. That's why it's important, as I mentioned earlier, that this is not obtained dynamically, because this is used to compare on the runtime. So, for example, if we do typo here, we will do something like, oh, it's camel case, not snake case. This would cause on temper to trigger because that's not the valid package name.
Mhm.
So yeah, we will basically add all of these to our list. Another one, let's take root. What root is doing is that is fired when shockingly root is detected. This, as I mentioned, this check is period, so it means even though the device is rooted on application runtime, it won't be much help because on the next check period it will be cough anyway. So let's add these. So what do we have next? Let's take emulator. I like emulators. So emulator is fired when emulator is detected. Emulator detect is considered not a safe environment since emulator knows or can be influenced way more than a regular device. So let's do an emulator, and also can be sometimes useful. For example, when someone would like to implement, let's say, FreeRASP in their game, and they don't want to some cheaters gain power by playing game on the emulator.
Interesting.
So let's do another check. Let's have on hook detected. On hook detected is fired when hook framework is detected. That's terrible explanation. Thomas probably can elaborate more on that. What is hooking anyway?
Okay, so hooking is like I like to answer this question like saying that it's like debugging. It's not, but you can imagine that when you debug, you can drive the application under your constraints. You can watch the application state, its threads, its resources, and hooking is quite similar concept. Hooking gives you the power to hook your application like to some environment which will allow you to inspect apps internals and modify it during runtime using various scripts you write. So you can basically like run the application and you are interested into some secret which will be generated in some future. So you will write a hooking function which will wait until that string, that secret string is generated, and you can then cut it out from the application once it's being run. So hooking is quite popular nowadays amongst penetration testers because this really speeds up the penetration testing. And we decided that it's important to have in Flutter apps, so we put it into FreeRASP as well.
So, if if you want to, Thomas, give maybe a difference between hooking and tampering. Um, I know that so Jaroslav actually explained about tampering, what it means, but it looks like they're pretty similar, aren't they? Or maybe not.
Not really. The tempering is much more about the statistical state of
I
application that
see.
something unexpected has been changed. So that's why you'll detect that your application has been probably cloned or something, some nasty stuff in this way. But the hooking is in fact a dynamic part of reverse engineering, and even your application, even your genuine application without any modification can be hooked. So hooking is performed on any application, and the tempering callback wouldn't even fire
Hmm.
on hooking this way. So hooking is another way, another protection we put in FreeRASP.
I see. Okay, so let's move on.
Mm, what do we have next? Let's say device binding. Yeah, device binding is another technique which I will explain very shortly, and Thomas then can elaborate. But it basically means that application is binded to its device. So when application is moved from one device to another, for example, when we are migrating from an old device to a new device, then this check is fired, because it can also mean that attacker is trying to gain some control by moving application um, from valid device to rooted device, let's say.
You want to add anything more, maybe, Thomas, to this?
Yaro said it perfectly. Like the perspective from the security standpoint of view is that there are in fact types of attack when an attacker can target your device with installed application. Like just imagine your banking application with all your funds and money and everything in it. So all this information is on your phone. But there is a type of attack when an attacker is able to grab the application with all the internals, everything it stores, and transfer it onto his testing environment, and then make another inspection, do other nasty stuff. So this transfer is protected by binding the application to the device. So the application is like locked to your device and won't be transferred or can't be transferred to another device with its internals. So that's the idea behind this control.
Okay.
Let's do one last check, and that's on untrusted installation, which was basically already explained uh, in supported alternative stores. It basically checks whether application was installed using from Google Play or one of the sources we provided here, and if not, then it's fired.
I see.
Untrust, untrusted installation. Boom, let's give the trailing comma. So right now we have our Talsec app. Now only what we have to do is call app.start. This
So
will
again,
start.
to clarify, Yaroslav, this must be in the root of the application, right? The first,
Mm,
like the toppest widget.
yes, it is basically recommended to run it as soon as possible, and also these checks should be, or in general, when some threat is detected, it should be treated as some global application state which moves from safe application to unsafe application.
I
That,
see.
that's the idea behind being the most important. But if you use some other state management, for example, plug or Redux or something else, you should just have your mental note that Talsec threads should have the highest priority as application state.
That's nice. So is it possible to have instead of in the widget, like a Flutter widget, like all the way up to main function, where we have run function to run an application, like before even widget binding is happening?
Mm, it is possible. What we that's question that the widget binding is happening, because when you see what all all plugins do is they call something like widget Flutter binding ensure initialized.
Yes,
This is important because this ensures that we can actually communicate with the native side. So if you would want to do all this initialization before this line, it wouldn't go, because the plugin has no way of communicating, no way of communication between Flutter and native. But after this line, you could do all of this implementation.
yeah, sounds good.
So let's remove it. That's app start. Let's do one last check. So we are supporting alternative store. We have correct. Seems all right. Let's run our application. And now you will see another thing which is in documentation, and it's often omitted, or I don't want to say ignored, because like who reads documentation, but yeah, uh, but it happens very often that we are running application in assemble debug.
Yeah,
Seems like right, when you develop application, it's normal that you are running in debug mode. The issue here is that it can, and very often time it even looks like that when it comes up,
like an attack.
it, no, the quite opposite. It looks like nothing is happening.
I see.
Like, I'm running emulator. Why is it not detecting emulator? That's the thing, that when you go to the actual documentation, there's this nice part called dev versus release version, which basically tell us when you are running in debug mode So we are doing assemble debug, the emulator, debugging, and signing. That means on emulator detected, on debugger detected, and on tamper detected is disabled. So what it really leaves is, let's see, this is disabled, we are not on rooted devices, this is disabled, we are not hooking, we are not moving from one device to another device, and ADB is allowed. So there's nothing to detect. So we very often, and also debugger is also disabled. So it very often times looks like, oh, it's not working. It is working. It's just debug mode. So
I see. But a question here: if I get an APK right now, oh, like in this APK is actually a debug release, let's say. But if I have a production release APK, let's say, and somehow manage to run it like with reverse engineer or whatever, like manage to run it in this way. So does it mean that we are kind of the attacker is bypassing FreeRASP here in this case, so they can actually, I don't know, do tampering or whatever?
when you have release APK, if you would release a debug APK to Play Store, then you do very bad thing because release debug APK contains way way more information than it should, and just no, that's big no. And second of all, yes, because what in the end what it does is under the hood, when we take a look right here, it uses debug implementation, which is just special version of FreeRASP, which is def, where are these checks disabled. But it wouldn't catch, for example, the disabled checks, but it would still detect, for example, root or hook.
Okay.
So let's actually run it on release. So let's kill this, stop all, and let's run in release mode. There is maybe one note. We are actually signing this release APK with debug key. Please don't do that in production. We're just doing it for the sake of demonstration.
Yes.
So while is it building, we can actually take a look. So right now, each one thing it should only detect is emulator, because we are running on emulator. But when we try later on to, let's say, misspell the package name or maybe broke this hash, we will see that it will detect tampering.
So another question, so maybe I don't know for both of you, we now actually hard coded in a string which is our release or whatever, like debug signing code, right? So is it a sensitive data? So perhaps it is for production. And is it safe to hard code it in this application?
In general, you shouldn't. Of course, you shouldn't hard code anything which is some kind of sensitive. So the traditional way of putting it into environment variables should be just fine here.
Okay, so then your recommendation is actually we need to remove that hash that we added there into an environment variable instead. So the hash that we added. So I'm just asking, like for those who don't know, we added a hash of signing key here, right? So is it safe to have it there, or should we also add it to the environment variable?
Hash is fine because hash is not really that, let's say, I mean, you should hide as much as possible, but when somebody see hash, it is not bad because hash is just, let's say, some fingerprint
Yeah.
of our actual signature. So that's fine.
Sounds good.
Yeah.
Especially, I think SHA-256. It's there is no way, at least as of now, to kind of revert it, right, or to go back.
Yeah, if you don't have quantum computer, then no.
Yeah, sure.
So yeah, in the meantime, we see that our application ran. Kotlin is yelling about bad version, and we see that emulator was actually detected.
Sounds good. So now this is good. So at least we know it's working. A bunch of question here. So this is a basic implementation, and we just added a string to a list to show in the application. But in a real application, we would not do that, right? My question to you to give us advice here: what would we do, like in a real application, let's say, if you want to just have some mechanism here? What are the best practices here? Like, for example, if we detect emulator, should we quickly get rid of everything, like a function here, and then shut down the entire application and just show, oh, you've been attacked or something like that? What's the best practices here?
That's actually very good question, and we got this question a lot. So that's why we created wiki page on FreeRASP community. There is the section threat detection, and there is quite nicely written how to react. For example, here for emulator, we have we have for, let's say, basic applications, we say just notify user so they are aware. But if you need to have rigid security, for example, you are a bank, then the most common answer is just kill it. So for example, in emulator, we would do something like, since we are killing, we are not caring about how it really kills it. If it kills, so in Dart, it's like exit 0 or 1 or whatever. Just small. I would like to add that this is kind of bad thing to do because it can generate like very ugly exceptions, but for the sake of security, we are, let's say, ignoring that or getting through the fact that this can generate some exceptions, because the main thing what we want to do is to kill.
Should I maybe give you like a proposal here? I mean, this is something that I also been working on and done that. So maybe here in this case, of course, we're just closing the application, but and maybe also, I don't know, if we already know which user is attacked somehow, is it possible? Is it a good idea to send that user maybe a message or something, say, hey, you've been just like attacked, that's why we just shut down everything? Or is that something that is viable to do? Do you think this is possible?
Mm, we I don't want to do marketing here, but actually we provide something like that on developer level. So when there's some attack on application, the developer of that application is immediately notified via email. But let's say from the perspective of FreeRASP, I think, or my opinion is that it is a good idea to use this function here, not to just notify, but also, yes, as you mentioned, maybe, I mean, notify locally, but also notify some externally. So for example, send some log to, let's say, Firebase or some other backend service. So yeah, I would say yes.
That's
It,
nice. Of course, it
uh,
depends. That's a typical question of software developers, right?
yeah,
But
yes, yes, this is the part where this is really just like opinionated thing, because some people will say let's just kill it all, you know, just I don't give a crap, just kill it all. But some are just like routing is like, it's okay-ish, tampering is no go, emulator is like, babe, that's okay, it's not a really big deal. Some people even say that device binding is not a real thing because he could just migrate from one device to another device. So there's really just matter of opinion here.
I see. I mean, for those who have not done that, so it's nice to tell them a bit about like the possible like prevention. Like you say, well, I mean, in you are expert here. If you say we can use exit, that's a way of doing that, then I think many people will do that without doing anything else. And that's the reason I'm asking right now. I just want to hear from you. Would you do, like in this case, as like an expert? So you're doing an application, you're using FreeRASP, you got a callback on emulator. So what would you do? Just quickly call exit, that's it, done? Or what? Or you're doing more stuff here? What are the best
Mm,
practices?
yeah, I understand. What would I personally do? That I will show. I would show. How is it called? Alert
Yeah,
for like, let's say, like 5 seconds, and which would basically say something really short and strong, like this application is running on device and will be closed
yeah,
soon. And after that 5 second period, I would just kill it, the application, because there is this thing that the more time you spend by informing the user that hey, there's something going on, the more time you
yeah.
give the attacker to actually proceed. So also we could discuss how long the alert should be. So for example, when we have banking application, it should be as short as possible, so we have the proper detection and protection. But otherwise, this is topic for hours and hours of discussion.
Absolutely. But can we just say, like, maybe Thomas can say that? Can we say, like, maybe one of the things that we can do in these cases, at least, try to shorten the time for attacker as much as possible? Like, if it's immediate call to exit, that's probably the best. Just do that.
I would say that from my experience, so from what I've seen, people like to do using RASP is that the most common solution is warn user, show some notification or widget, and kill application. This is the most common case. But if you want to be creative, you can set up some smart strategy. And latest OWASP standards is going this way that you should have some alternate, like spoofed behavior of your application to not alert the reverse engineer or attacker that you know about him, and that you should, for example, proceed the operation but with some fake keys or fake information. So you can basically, base is kill or warn and kill, but if you want to be fancy, you can get some special strategy and try to confuse an attacker.
I see. That's nice. Um, Before we go to the final words, I would love you, Yaroslav, to show us quickly what are the callbacks for iOS as well. Very quickly, just touch on that. You don't need to add anything there. Just explain the callbacks and the attacks.
Yeah. mm, Actually, I will do something like, I'm not adding them, I'm just so people can see. So let's do iOS, and let's do this. Yes. So these are callbacks for iOS. Unofficial store detected. It's pretty clear. On simulator, that is equivalent to on emulator, but Apple guidelines just say it's a simulator, not emulator. On signature detected is equivalent to temper. On runtime manipulation, that is equivalent to hook. Passcode detected is called when um, passcode of a device is changed during runtime, which is a thing. I didn't even know when I was implementing this.
Interesting. Yeah, I didn't know
Yes,
that.
I was I mean, it's mostly like when you run application, then you just you minimize it, then you change your password, and this is called. So on missing secure enclave is a security feature of Apple devices, and if it's missing, then it means that A, it's old device, or B, it is a fake device. Jailbreak is just equivalent to root. Device ID is equivalent to device ID and device change detected are quite similar to device binding, but they are a bit different.
Okay.
Maybe Thomas could elaborate more on that.
Not really. Like I would have to check the documentation, but I know that there was some small nuisance between the changing of device and like updating of iOS, which led us to this decision to split this detection into two parts, and you can better understand in the documentation.
All right, very nice. Thank you very much, both of you. I think this was very interesting, and you see that I actually didn't speak too much. I was just paying attention what you're doing and you're saying. It's actually nice. So usually at the end of the show, I will ask my guest to just tell me the final words as well as the best practices, whatever they want to add, to that things that they mentioned during the talk, as well as probably if there is any plan, roadmap, or anything, or any way that people can communicate with you. So, stage is yours. Just tell whatever you want to say right now.
So I'll start. So, as we saw today, security, even for Flutter, is not really hard. I know it maybe sound cryptic for many people that security there, security that. You see hash, you see SHA code, you see many other things, and you're just about to explode. But that's not the case. Security is for everyone, and it should be for everyone, and it should be easy. That's what we are trying to do. So please, if you can, please try our FreeRASP. If you have any issue, you can open issue on our GitHub repository. And even if you want to contribute and make FreeRASP better, we are open to pull requests or any other feature requests.
Thomas.
I'm thrilled that we managed to get this technology available to general public, and that's really something I'm proud about. That anyone can use RASP in the application for free today. And speaking about roadmap, we are preparing some discussion forum about mobile security for the future. So stay tuned. We will roll out something in the future which will be really groundbreaking in the mobile security field.
Nice. Thank you very much. Is there any way that people can connect to you? Like, should they come to Talsec.app website, or the repository for FreeRASP is good enough way to start?
You can they can connect it with us using GitHub you mentioned. They can write us email. They can find the address in talsec.app. They can tag us in social media, Twitter, LinkedIn. They can directly even tweet me or Thomas. We're fine and we are open to any relevant comments.
Fantastic. Thank you very much, both of you. And thank you for watching this video. See you in the next video.